Alrighty guys, so here what we're looking at is a bit more of a challenging example where we've got the period changing on our trigonometric function. So normally you'll just have sine of x or sine of theta is equal to an exact value. But here we've actually got sine of 2 theta, which changes the period, we know, is 2 pi over n. We can figure it out. So n in this case is the 2 here. So 2 pi on 2 is equal to pi. So that means after pi it's completed a full revolution of the circle, and then if we're looking at it between 0 and 2 pi, it's made one revolution and then able to go through all the way through again to get to 2 pi. So in our previous examples, when there was only one revolution, we only have ever had two solutions for x or theta. But in this case, we can see when is sine of 2 theta equal to a negative half between 0 and 2 pi. Negative a half is here. Actually see, it goes through negative half at 4 different x values. So rather than having two solutions here, we're going to have 4 solutions. If you don't quite understand that, that's okay at this stage, as long as you can go through the working out here. So our first step always, when we've got a change period, is to just make, let's just let 2 theta equal to x, which puts it into a style that we can actually solve. So sine of x now is equal to a negative half, using that basic substitution. Alright, now step 1, just like before, now it's just a simple question like we were looking at in the previous video, is find the reference angle. So when is sine x equal to a half? So I'll just get us back across here. Sine x is equal to a half at pi on 6. Okay? So x is equal to pi on 6 as the reference angle. But we know that that's not one of the solutions because we're looking for when is sine negative. Sine is negative. Look at our unit circle. Sine is negative in quadrants 3 and 4. Okay? So quadrant 3 and quadrant 4. Okay? So for quadrant 3, you can pause the video here and find values if you'd like, if you're feeling confident. Find values in quadrant 3 or quadrant 4 using this reference angle. So for quadrant 3, theta would be equal to, using our unit circle, pi plus pi on 6. Go back and look at your unit circle if you're unsure of that, which is equal to 7 pi on 6, because you just got a whole pi, adding an extra 6 give you 7/6. Or theta is equal to, in the fourth quadrant, 2 pi minus pi on 6, which is theta is equal to, so that's 2 whole pi's minus 1/6, that's leave you, 2 whole pi plus pi on 6 leaves you, with 11 pi all over 6. So that's 2 out of those, but we know, because the period's been shortened, we're going through twice, we're going to have 2 extra. So to get from this one through to this one, we'd need to add a whole extra revolution. So we'd need to add a whole extra 2 theta to find all the values here. So theta is equal to 7 pi on 6 plus 2 pi, and same one here. So we've gone through one revolution. To get to the next revolution, we just need to add on 2 pi. Okay, so theta is also equal to 7 pi on 6 plus 2 pi. That's 19 pi on 6. So I'll just, and that's 23 pi on 6, because 2 pi is just 12 pi on 6. Okay, so sorry, my mistake here, you guys are going to hate me for it, but we're actually not working with theta, we're working with x all the way through because we made that substitute. So x is equal to 7 pi on 6, 11 pi on 6, 19 pi on 6, and 23 pi on 6. But, so rather than working with theta up above those ones, we're actually working with x there. I apologise for that mistake. But we know that x is equal to 2 theta from our initial substitution. That's what we're trying to find, theta, not x. So therefore, theta is just equal to x divided by 2. So we just need to divide all these x values here by 2. Alright, so 7 pi on 6 divided by 2 is just 7 pi. The 2 just multiplies in the denominator, so that's 7 pi on 12, 11 pi on 12, 19 pi on 12, and 23 pi all over 12. So all you do, so x divided by 2, dividing all these fractions by 2, just doubles the denominator. And that's the most difficult question you can get in this area, guys. So it's a bit long in the first one. So when you do the first video, you should be all set. This is a bit more advanced, so hopefully some of us will be able to get to that as well. Good luck.